Okay, now we're rolling. So thank you everybody for coming here to this open source compliant done right with Opossum talk. Technical thing, you can, if you're following remote, you can post your questions on Slack and I will be asking them at the end. If you're here in the room, I will be taking your questions in the old analogical way. So I'm happy to introduce to you the two speakers, Michael Cheng from Facebook and our very own Max Hübner. And now I will just give the talk to them.
So yeah, we will start with introducing ourselves. Hi, I'm Max. I'm with TNG now since 6 years, where I started as a nerd and quickly became a open source license compliance nerd, since I went into a project where we developed Fossology, an open source license compliance tool, and there I got the chance to become maintainer, and then the next tool, SW360, where I also became maintainer, and now I'm working in this ecosystem and learning more and more and integrating these tools into each other. And it's a huge pleasure, and it's actually a nice ecosystem where you can take your project to the next customer and you can keep working on that even if you work for a customer that uses something else. So it's a nice ecosystem in that. And I had a plan. I lost my plan. Let me take a step back. So yeah, there I collected all this knowledge about license compliance. Now here at TNG, I work with in several projects where we integrated this license compliance tool chain at several companies, where we help to get that running, where we help to fix stuff, where we implemented custom features. Also in technical due diligences, we apply these tools to get a fast and good understanding of a code base to understand what's in that. And within TNG, I do some consulting work where I help other teams to understand how license compliance works, what they have to do, what they need to adhere. And within that scope, I gave several talks, some in Japan where I met Michael. So
hi everyone, I'm Michael Cheng. I am a product manager at Facebook supporting open source and standards across the company. So I started out my career as a network engineer, spent 10 years as an M&A lawyer, and most recently I led the product, intellectual property, and commercial functions on the M&A legal team at Facebook. So I get asked a lot about my role, product manager for open source. What does that mean exactly? Well, the short answer is I help people build products in the open. Open source means a lot of different things, but one thing it means from a product management perspective is it represents a trend of products being built inside of companies to companies being built in the public space. Once upon a time, there were clear boundaries between what was internal to a company and what was external. Those lines have blurred or are now non-existent. Where once products were built by employees of companies, nowadays products can be built by individuals, governments, academics, and organizations of all sizes working together on the same project. So what I do is I create the tools, frameworks, and programs to help people build products seamlessly together in the open. And regardless of what side of this boundary that they fall on. And today we're here to talk about one of these tools, the Opossum tool. So why the Opossum? Right? Well, the opossum is a noble creature that has a very wide palate, right? It eats anything and eats everything and it enjoys it, right? Specifically, it eats a lot of trash that no one else wants to eat. And so what does this particular opossum like to eat? Well, it eats debt, specifically the debt created by high velocity software development. Today, innovating and iterating in software at the speed necessary to keep up with the competition means trying lots of things a lot failing quickly, and trying again. The speed of software development requires the use of enormous amounts of open source. And every company in the world, in order to compete, will need to one day become a software company. And eventually will want to iterate at the speed that involves using this much open source. Using this much open source creates debt, and that debt occurs when moving from development to production and finding out that large parts of your stack are incompatible with your use case, either due to a legal reason stemming from not having the right to use the open source for your use case, or more importantly and more likely, a security reason from having a security vulnerability or a loophole. In short, Opossum addresses the legal and security debt created by high velocity software engineering by helping us understand where the code comes from, what is its history, and whether it's compatible with our use case. The goal, of course, is to enable engineers to treat code that originates outside the company as if it were coming from inside the company, accelerating the velocity as software is built and the speed at which organizations are able to innovate. Up next, Max will talk a little bit about the problem space. I'm going to then talk about the overall blueprint, and Max will talk about the UI, and then we'll wrap it up from there. The big takeaway that I hope everyone walks away with is how easy it is to build these kind of systems yourselves. And if your company is looking to scale and integrate, looking for a system that scales and integrate with your growth, you'll definitely want to build it yourself. All right, over to Max.
I want to start with just explaining where does this issue come from and how we can find it in the wild. So the first basic example, just a very used and very popular open source component, jQuery. That's the first part of the source code of jQuery. It contains a header. And if we look there, that header contains a section that says something about copyright and the license. And that's the interesting part. That header tells us this file is owned by the OpenJS Foundation and its other contributors, and it's released under the MIT license. To understand what that means, we need to look into the license text. That's the MIT license specifically for that component. So that also contains the corresponding copyright header. And if we dig into that, we see that this license permits us to use and publish and do stuff with this component, but it still has some conditions that we need to adhere. We need to, if we distribute the component, we need to provide the copyright and the permission notice and the included disclaimer here with the component. So we have something to do if we use that component. Okay, that's easy to understand for a single component, but how many components are there? So let's one step back again. Let's start from an empty project and let's add jQuery. That's the state that we were in just now. We have a Node.js project that has one dependency. It has a dependency graph with one edge, and that is jQuery. So that's what we just understood. But now the interesting thing is if we add the next dependency, it just somehow often explodes. The next dependency adds another 325 dependencies in a graph with 686 edges, and it just quickly grows out of bound for humans to follow that and to understand what's happening there. The quality is not perfect, but you see it's just a total mess. And somehow we need to understand that. So to summarize, what do we need to accomplish to have to ensure compliance in our software development process? We need to find all involved third-party components that are used or distributed or somehow related to the product we are building. We need to understand in which context are they used and how are they used. We need to identify for every component what are the applicable license conditions and copyright. So we need to do this, look into the source code, understand what is it referencing to, or somehow research what the conditions are. After we have these conditions, we need to understand how do they, is there a license choice involved? So can I choose one or the other license? And if I have done that, how do these licenses interact? Are they compatible? And are they compatible with our own policy? Do they violate some rules that we have set for ourselves? Do they conflict with the intended use of the product. So maybe the license has conditions that we cannot implement in this specific product. And in the end, we want also to have a way to follow all these implied conditions in an easy way. So that's the main goal we have. And there are several approaches that can be found in Wired how to do that. So the first idea is, oh, that's annoying. We just don't use open source. We do a complete ban of open source. We say we developed it ourselves. But where's the fun in that? That does not work. That cannot keep up. That's not realistic anymore for most ecosystems. The next approach often is, if we have to approve everything, if you have to understand everything, let's establish a process. Let's say, hey, every component that gets into the system, that gets used somewhere, somehow, it needs to be approved by a group of experts, by legal. But as you have seen before, that's also probably cannot keep up and just has scaling issues. The next approach is the pay a license fee and boil the ocean approach, where you have some commercial vendor that provides you with a database of fingerprints, of hashes of files, and you scan your source code, you scan everything, and you try to label everything according to this information to find for everything an origin and filter through false positives. And in the end, you get some consistent set of license conditions for that software product you scanned. But that's a complicated and actually annoying path to take that has a lot of work included and thus adds a lot of transactional cost to the usage of open source. And the last way of solving that we want to talk about here is just build an automatic pipeline that's deeply integrated and that helps to tackle the problem itself and build it from open source.
Yeah, so this is a comparison chart that shows you the pros and cons of building your own solution versus buying it from someone else. And when we were building this, after we finished building this, we were like, this is not very interesting or original, right? This is not unique to this problem space, right? Literally every single 5e build chart looks identical to this, right? You remember in the 90s, in the early 2000s, I did a short stint selling open ERP software, expense, regret, and pain, right? And we had a chart just like this. We were, as part of our sales pitch, right? But what I think is interesting about this chart is that in almost every enterprise industry, there's always a spectrum. Some people choose this because it's easy, and larger players to scale, they choose that. It's pretty much the same, right? In this space, in this segment, overwhelming majority of folks choose this. Nobody chooses that, right? Now, why is that, right? It's a function of a couple possibilities. Why one, of course, is that cons are really not that bad. Pros are really not that good, right? But actually, when I think a little bit about it, as I was listening to Max talk here, what I realized that this is, we didn't mean for this to happen when we were writing this, but this is a timeline, right? This is a chronological timeline, right? Yep. Because this is what, and the top, is like 20 years ago. Linux is cancer, right? That's the top line, right? And then it's like, oh, okay, you know what? Yeah, we'll let a few through the gate, right? Well, yeah, just a little bit, right? And then this is where we are now, right? This is the state where we are now. And where we are now is that everyone is choosing this, right? And so what is really happening is that the demand side of the market is not mature. There isn't enough demand side supply. And when the demand side matures, gets bigger, when this thing happens of every company becoming a software company, we're going to see a much more mature supply, right? And this is where we see, even though it's open source, this is where we see the quote unquote the opportunity in this space, right? Is we see a lot of pressure on companies to build it themselves. And that's where Opossum fits into this space, right? And these cons are where we have been doing most of our innovation, at figuring out how to reduce these cons, right? So the tool that Max is going to talk about, Opossum as a whole, is aimed at reducing the cost of initial setup, right? And larger, broader collaboration is aimed at, that we're going to talk about in a bit, is aimed at reducing the internal headcount necessary, right? And now we're going to talk about how. So no question, as Max has shown you, it's a hard problem. It's so hard that when faced with this situation, it was not unreasonable for many companies to throw lots and lots and lots of people at the problem, right? Even with this solution, you still need a lot of manual review, right? And when we went out there and surveyed the industry, we found that lots and lots of companies were employing teams of 25 to 50 people whose full-time jobs it is to go through the source code, review what's happening, right? And we thought to ourselves that this can't possibly scale, right? And there has to be a better way. And there must be a better way, right? And to build a better way, we had to understand the old way. So we went off and spent months, which felt like years, doing this manual work ourselves over and over again. It was really, really hard work. And there's a couple of things we learned. First, we learned that context is everything, right? Context about the directory tree structure, context about the design of the product, context about what you've seen before and where you've seen it, context about the purpose of the specific components being used in products. All this context helps a reviewer decide where the problems are, and more importantly, very quickly, where the problems are not, right? We learned that context that is external to a source code is often going to be much more valuable than information that you find in the source code itself, right? You're not going to get good signal without this building this context into your system. Next, we needed something that was extremely lightweight and capable of growing to infinite scale on cents on the dollar with negligible incremental costs. So no matter how big you got, how many products you had to ship, you only had to pay an extra $100,000 or whatever, a very small amount, right? Finally, we wanted a system that was modular, extensible, could talk and work with as many of the existing tools as possible, and it could adapt and grow over time. Out of this, we realized that there were two critical sources of information. One was information in the source code, but also contextual information learned by people doing the manual analysis and doing the quality assurance. No matter what system you use, you're always going to have somebody doing the QA, and the logic, the wheels that turn when they apply the identifications are always going to be helpful. In terms of information from the source code, we came up with 3 different types of scanners. One was a metadata scanner that parses machine-readable information from manifests and the build system. The second was a source code scanner that parses mostly human-readable or partially human-readable machine data from the source code and arbitrary text. We use a tool called Scan Code Toolkit. And finally, there was a knowledge-based scanner, right, which computes hashes and fingerprints and combines it with historical contextual information from previous loops. On top of that, we built a manual curation loop to extract the valuable contextual information from experienced developers, legal experts, and other people who could enrich the data, right? And then we fed all of that into what we call a merger tool, which helps parse the information, make decisions, and automatically identify more and more and more of what comes to the system. It started with something like 60% of the things coming through were being automatically identified. Today, we're up to 95%, with the goal being 99% at some future date. And the goal, of course, is to shrink this manual review team to nothing, right? So this is a time travel movie, right? Where you're stuck, you're playing the same day over and over again, right? And each time you go through the movie, you get better and better and better. The point, of course, is to break the loop, right? So how do we break the loop, right? One way that we do that is we collaborate openly on this data, this contextual information that we create, right? This is information about publicly available software, right? There's no reason why we shouldn't be sharing this information openly. The more we do it, the lower the cost will be for everyone, which is why we open source the first part of this tool, the UI, which Max will now talk about.
So I will start with, I will describe the UI. So the UI is the piece that helps to implement that feedback loop, that helps to understand all this generated information and to helps to put that into context and to helps to resolve conflicts within that information. And for that, we chose to build it as a independent desktop application that is built on React and runs within Electron. The architecture is something like it takes a JSON input file that just describes the whole relevant universe for that scan. It contains all the signals, all the information, everything that is needed to get in context of that scan. We put that into the UI where you can review it and understand that. And in the end, after this process, after the corrections, you get output out of that. That is, on the one hand, on our specific output JSON format that is just tailored to be just the information you need to reuse that for the next scan and just the corrections. We have we can generate a bill of material format in the form of an SPDX 2.2 Lite document that is supported by a huge amount of tooling and that is actively pushed by the Linux Foundation to be integrated in more and more tools and toolchains. So we plug into that nicely. And we have some other output formats that are CSV style lists that you have a question? Yeah.
Yeah, remember that it's become official ISO formats, SPDX since last week.
Yeah.
So yes, that's why we rushed to build it in.
Yeah, that's a huge accomplishment by that community to push that until it's being an ISO standard. But yeah, SPDX 2.2.1 is now an ISO standard. And it's similar to 2.2, so that's compatible and that's the ISO standard format. Yeah. And so yeah, and the source code for that tool is on GitHub. You can just look there and open that and also download releases and just try it out. I will show it later. But first, let's go bigger and look at the bigger context of that tool. So now that tool is on the right. And here we answer the question how to generate inputs for that tool. So you somehow need to compile the universe, all that knowledge into that single JSON. And for that, we have a fork of the very prominent OSS Review Toolkit project that is a huge player right now in the open source compliance ecosystem. And we built that to just convert arbitrary information from scans into our format. So we naturally plug into that. And we have the second library that we built that is extendable, is a library that already can pass several formats like the scan code JSON output, the dependency check JSON output. That's an OWASP tool that is security focused and brings the security view into that tool. We can pass SPDX 2.2, the full and not just the light version, and put that into the tool. And we have a proof of concept that can consume ScanOSS information. That's an open source snippet and fingerprinting SCA tool. And we also have a proof of concept that is not yet public that can pass turn outputs that help us to visualize the context or the content of Docker files. And the two mentioned projects are also on GitHub. Same space, easy to find. We will show the links later again. But to zoom out a little bit more and to have it on a slide, it's shifted to the right. You need to generate these intermediate formats that we can consume. So you need to run these tools and you need to deploy these tools, and that's also annoying and that's complex and that are also huge. These tools themselves are huge, actively developed tools. So we built a convenience project that just deploys all of them in a single Docker image that you can just generate yourself with a one-line command. That's the first command here, the build Docker image command. And we have a second command that can run the resulting Docker image on a source code folder. And that's an all-in-one integrated thing that just consumes source code and produces output for our toolchain. So deployment is easy now. And it's also in the same space, and we will point to that later. But yeah, there's the fancy slide that says demo. And now we need to see it's working. So that's the tool. I hope it's correctly shared and everything is working fine. I get a thumbs up. That's perfect. So yeah, that's how the result looks if you open that in the tool. That's the scan of the Qt browser. That's a browser written in Python with some, I think, Chromium internal, something like that. I don't actually know. I just have analyzed the project, and now I can go through that. I see the file, the source code file tree here. I see there's a .github folder that contains stuff where the tool didn't find anything. We have some folders that are red or blue that are different kinds of there's something to do. Red means there's nothing yet resolved. Blue means there's partially something resolved. And I can go through and click at stuff. That's basically what you do with an UI. I can click here. That's the first thing, just a random file. And now I can look at the details and see that that's a file where scan code found a license information and a copyright header. And that's just signal I have here. And my goal now is to understand what is contained in this source tree. So I can go back to the top level. And the first thing I see is here's AngularJS in the project, and that gets this red icon here to mark that it's a follow-up. That's something where something is to do. I can click here and navigate to that file. I see that file is in the tests folder. There's something called hints. So it's test data. That's probably something I can just ignore. So I can just say, hide that information. That's not important for me. And I can start that way resolving stuff. And I can say that's Qt browser test data and just hide that for me. And so I can just resolve full folders. It's a tool that helps me to understand the context. And we integrated the OSS review toolkit into that. Now I have not yet shown the features from that. The OSS review toolkit helps me to that's annoying. Helps me to get package level information. So if I go back to top level, now I see everything that is contained in the source tree. I see I have 73 places where the zip library is used. I can click here. I see it's a transitive dependency of some dependency of some files. If I just open one of them, I see now I see here in this file tree, there's this requirements file that specifies dependencies in this Python project. And what we did is we placed the dependencies specified in the project in a file tree structure below that file. So we can navigate here. And in the same way as we can navigate through the source code of one of the project, we can now navigate through the source code of the dependencies and understand the dependencies. So the first direct dependency is check manifest. And I have here the source code of check manifest. I see the scan code finding for this project, and that helps me to understand the what's in that. I can double check whether the so the tool provided me the information that check manifest is under MIT. I can double check by looking around. I see there's something. It tells me it thinks it's GPL 2.0 or later, and now the I can open that file in the browser, and that brings me here, and I see that's that file. I can search for GPL, and I see in version 0.14 they changed from GPL 2 to MIT. Yeah, that's this finding is obviously a false positive. I'm not interested in that. I can just hide that, and that way you can resolve all the information. And in the end, the top progress bar is completely green, and you're done. And you have convenience features like an overview or an inverse view that helps you to understand what dependencies are there, where are they used. And we have a report view that gives you a bird's eye view of all the dependencies and highlights where something missing. So the copyright information is right now missing for most of the components. That's potentially something that's in the tool chain not yet fully implemented or missing. Here I have a component that is missing a license, and I can start fixing these things. And go here, see that thing is missing a license. Which file is that? I can go here, and so that's basically how you dig through the source tree and produce decisions. And in the end, if I'm able to go back to the presentation, that implements this loop. We get all the information here. We see all the information in the UI. You correct that. The corrections get put into this database where from there they are reused for the next run, or you directly fix stuff that is wrong in the source code So that is the very, very short demo of Opossum, and you can try it out yourself by just trying it. But we will come back to that.
Yeah. So the reality is that it took a lot of work and a huge investment on our part and on TNG's part to get where we are today, right? The next group of people who come along and make the choice to build it themselves, it's going to cost them a fraction of what it cost us, right? And then so on and so forth, right? And the hope is we get to a point where it starts to snowball and the costs are so low, the technology is so easy to use that this collection of tools, and it might not be Opossum, it might be something that replaces it, it might be some other thing, right? But this collection of tool on that chart on this right side of it becomes not only a viable competitor to the proprietary solutions, but it becomes the only option. It becomes the only option, right? But in order for that to work, we need people to make the same hard choices that we did in wanting to invest in going your own way, right? And we hope, for the folks watching this here and remotely, that we can work on this together, and we look forward to working with you. So thank you very much. That's the end of the presentation. I wanted to extend a big thank you to my partner, Max. Funny story, I met Max randomly in Japan in 2018, and I was introduced to Max by someone else who was trying to sell me something. And right away, I could tell that Max was the guy to talk to. But this person who wanted to sell me something so Max and I would make eye contact with each other. And then this person would, so kind of a comedy, this person would just jump in to kept preventing us from talking. But eventually we got together, and I'm really glad. We've been really blown away by how fast TNG has been able to prototype and build this. The system you see before you today was built mostly in the course of 6 months to a year. And we were able to meet a lot of our internal goals in under a year when we had projected that it would take more than 3, right? And so TNG has been an amazing partner for us. I also wanted to thank all the folks at TNG who worked on this. Anton Bauhofer, Benedict Richter, Benjamin Patek, Jacob Schubert, Jonas Tai, Leslie Lazzarino, Nico Carl, Sebastian Thomas, and of course, I also want to thank my old manager, Alma Chow, and my teammate, Adam Wolfenden.
I want to thank you for having the chance to be part of this and to having the chance to work with you at pushing that industry in the direction of open source. And it's nice to work with you, and I think we will continue that.
Yes.
And if you want to learn more about the tool, we have a space on GitHub that contains all the mentioned projects, and is there you can just try it out yourself. We have there's the Open Chain project, and we participate in a case study there. They promote it as the biggest case study yet, and we are helping them and you can find more details on that on the OpenChain project page. And there's also the open source tooling working group. I think I missed the working in that. It's such a long name. And they are a group of companies that try to integrate all these open source tools and are also actively working on that space. And we relied a lot on their work and their results. So that's it.
Thank you, Max and Michael, for your talk. Are there any questions? Please.
It's a bit of a fashionable question, but I wonder, in this loop that you're creating, where you want to have the curator disappear, when an obvious question is, should there be artificial intelligence partially automating that? Have you thought about where that would come into place? Is there a natural hook that one would connect to make a decision engine play a role?
Yeah, we've talked about it quite extensively.
I think we should repeat the question first. Yeah. So the question was whether in this loop, in this feedback loop, we could add artificial intelligence and where it would match. So,
yeah, we've talked about it quite extensively. It is one of our next goals for next year, right? I think the trick, of course, is to really drill down on a very specific question, specific yes or no, the question that can be trained and that's like applicable, like for that. And for that, we need like the right data sets and to prepare the right data sets. So we think that there is some benefit to it. I'm not completely sure how useful it is, but it's definitely something we're going to try.
I had two questions. One of is already there, but we did something similar with machine learning. It's a part for the year who's coming out for the compiler services, and we are thinking about doing the same with the resulting of this too. So we already came with something there. But my question is about why you are running twice scan code. If you can get the same results of the time that you use in ART, the same results, then you can actually upload there. There's a special reason to that?
Yeah. Let's go back to that slide. So the question is, in that slide, there's scan code toolkit managed explicitly, and there's the OSS review toolkit that in itself runs scan code. So the OSS review toolkit runs scan code on the source code and runs scan code on transitive dependencies. That's even more than we do. But at the same time, the OSS review toolkit does not provide us with all the information that scan code got. So scan code finds more than just license and copyright statements. Scan code finds dependency information.
This is completely correct, but the fact that you're already running a scan code toolkit from Nords, from the open source toolkit, it means that you can pass all the parameters and get all the results that you get automatically there, even from the scan code. So there's no reason to run twice.
Yeah, that would be a way to optimize that. So the second question was why don't we just put the scan code toolkit into the OSS review toolkit and run it there with all the parameters? The problem is that we rely on the intermediate chase format that the OSS review toolkit just saves, and we use that as an input. So we have here the document that OSS review toolkit contains, and that file format is not able to represent the data that we want. That file format just contains this file had this license, this file had this copyright, and that's all that we get from scan code. And we would need to improve that to provide us with the full result, and then we could use that.
Okay, that I get both results from one single run, even from the scan code. Both scan code JSON, unless it's possible to do it that from one single run. I can actually show to you then.
Yeah, and I think we've been using primarily scan code without. I don't think we've been running it twice. I think we've been just using primarily scan code.
Yeah, there's OSS review toolkit is just in the open source AIOP project, and that is run twice here. Are there different questions?
Okay, let's have one from the back of the room.
So sorry for being in the back. Doing this analysis manually is really hard, about to be impossible, kind of, to really thoroughly do it. you automate it in kind of a way where it could in future, in principle, be possible to just, well, do it automatically completely to a large confidence level. The question is, if you think about the legal perspective of that thing, if you have a completely automated process, where's the responsibility in that kind of thing? And do you think that somewhere there could be a stage of that the tool approves the software and then you have done your responsibility to check the licenses, because it's a huge impact if there's something in there that is still not correct?
Yeah. Do we need to repeat the question? Or we?
Yeah.
No. But he was on mic, right?
No,
I got the mic, so should be fine.
Yeah. So the tool that we have. So first of all, we definitely see when we first conceived of this tool, we thought about a knob, right? A sliding scale, right, of risk that your organization was willing to take, right? And then when your organization was willing to take less risk, when you slide the knob left, right, the confidence intervals for the decisions making would expand, right, and vice versa when you go the other way, right. The tool is designed in a way to not make judgments, right, about. And so we think that the particular risk profile that you want to take is based on the industry that you're in and the specific product that you're designing. So the tool that we have is agnostic to that, because we want the decisions to be made by the organizations themselves, right? But yes, we do think that there is a world in where the quality is so high, right, and the changes between releases are fairly minimal, right, that things could be automatically approved with zero human intervention, right? Especially if the change set between versions is within a certain small amount, right? Then it's probably that's actually very reasonable, right? But if you're talking about approving big brand new product release launch, doesn't seem prudent to rely completely on something automated.
Yeah, me again, sorry. What I'm wondering is about ecosystem stability. For example, let's assume we would be in soccer. I assume in 10 years Bayern München will still win something. But here are many different components that you are using, integrated in your tool chain. How did you decide on betting on them? Or do you assume they'll still be there in 10 years? Or is it not really that important because you do have, say, demonstrator move through of the data and the processing, and even if a component would be unreliable in the future, you would simply replace it?
I think that's one of the advantages that we are in the open source ecosystem. We take components from open source. So if the main company or some organization that is pushing that open source component would say, we decide differently, we now do something else, we still have access to that source. We still can fix stuff ourselves. We are not dependent on them offering the paid service. They are not depending on them, still have the same on-premise service and keep that for the next 10 years. We are in some way independent. And our feeling is that we set on the larger players in this ecosystem. And there's a greater group of other companies that also do the same, work in the same direction. And so I don't think that one of our choices will soon vanish or will soon no longer be supported. And even if we can handle that ourselves.
The heart of the system is Scan Code Toolkit. Yeah. We are very, very dependent on that.
Yeah, we are
extremely dependent on that, right? And so, Philippe and his team, we really, if you're listening, we really, but it's just not us. Right. I would say that the companies that depend on Philippe and Scan Code Toolkit, many household names, many household names, trillions of dollars of market cap depending on this one tool. Yep. Right. And so I think in that sense, now that I'm listening to myself talk, I think we probably need to do more to support Philippe. But it's a really great point, Henrik. And I would say the other part of this is that we do hope to inspire competitors, right? And so like the benefit of the standardization is that all of the competitors will hopefully converge on that standard, right? Making interoperability a lot easier.
Let's say that the better, we are talking about the open chain group about actually the most important is actually interchangeable format that to be standard. So if you have a better tool than scan code in the future, the format is the same. You keep continue the code. So this future is you keep the format standard, but not necessarily the tool itself.
Yeah. So we want to, hoping somebody listening will start the Hortonworks version of this company and sell, not sell the software, just sell the professional services, right? Yeah.
So first of all, thanks for the talk. It was really interesting. I have a bit of more an open question. I mean, we saw open source going from kind of, nerd enthusiasts on their free time doing things to a multi-billion-dollar industry right now. And what do you think the open source licensing is where it's going to evolve in the future? Are we going to see more consolidation towards, let's say, a few licenses, or is it going to be more of this explosion we've had in the past? Difficult question, I know.
I think this is a topic that I think every person has an opinion on. I will say that the current structure of open source is not built to withstand or built to support the big change that's happened, which is most of the users and consumers of open source are large companies, right? And companies trying to make money, venture-backed companies with very, very hungry venture-backed companies, right? And it's not the same. The relationships between companies are built by my tribe, are built by lawyers, right? Open source was not built by, open source was built by a lot of good faith. And so I worry that a lot of the economics of the low transaction costs of open source, right, will not exist in the future, right? Because, companies that are hungry, venture-backed, they may exploit some of the good faith, right? And the transaction cost will go up, right? And this is more and more licenses equals more lawyers needed to read the licenses equals more money needed to be spent on collaboration. And that's not a good thing, right? And so this tool, I hope, is one of the ways that we lower the costs of transacting in open source, right? But and I hope it's enough, but I suspect that there will, in addition to more licenses, there will be other things that will threaten to raise the transaction costs of open source.
Are there any further questions?
Are there questions from Slack?
No. Monitoring them. So then, thank you again for your great talk, Max and Michael. And thank you, everybody, for attending.
Thank you, everybody.